Hello everyone. In this video, we are going to discuss about insertion sort in data structures. This is the basic outline of this video. This video consists of introduction to insertion sort and an example, a C program, time complexity, advantages and disadvantages of a insertion sort. Before starting this video, please like the video and share the video. It will help me to do much more useful content. Now let us look what is meant by insertion sort. Insertion sort is a simple sorting algorithm that works by iteratively inserting each element of an unsorted list into its correct position in a sorted portion of the list. Here, basically, the input is an unsorted array. We apply insertion sort algorithm to it, and the final resultant array will be an sorted array. Let us look into the steps that are to be followed in the insertion sort algorithm. Start with the second element, as the first element is assumed to be sorted. Now compare the second element with the first element. If the second element is smaller, then swap them. Then move to the third element. Compare it with the first two elements and put it in its correct position. Now we have to repeat this entire process until the complete array gets sorted. This is the algorithm of insertion sort. Now let us understand clearly with the help of an example. So here the input is an unsorted array of 5 elements 12, 11, 13, 5 and 6. By applying insertion sort in the first pass, we will select the second element as the key value. Here 11 is selected as the key value. Now 11 is compared with 12. If the key value is less, then swap it. Here 11 is less than 12. So in the first pass, we need to swap both 11 and 12. So this is first pass. Now after the second, in the second pass, we will consider the 13 as the key value. This 13 is compared with the first two elements. If 13 is less, we will swap them. Now 13 is compared with 12. 13 is not less than. Now again 13 is compared with 11. 13 is not less than 11. So no need to swap. This is second pass. In the third pass, we will select 5 as the key value. This 5 is compared with the rest of three elements. If the 5 value is less than the elements, we need to swap them. Here 5 is compared with 13. It is less. 5 is less. So we will swap both 5 and 13. Similarly, 5 is compared with 12. Here 5 is less. So we will swap both 12 and 5. Again 5 is compared with 11. Here 5 is less. So we will swap both 5 and 11. The resultant sorted array after third pass will be like this. In the fourth pass, we will consider 6 as the key value. Again, we'll compare the key value with the remaining elements. If the key value is less, we will swap them, else we will not. So after comparing the key value with 13, 12 and 11, here 6 is smaller. So we will swap the 6. Again, we'll compare 6 with 5. Here 5 is less than 6, so no need to swap. So after the fourth pass, the complete array is sorted and no more iterations are possible. So this is the resultant array. So this is the insertion sort algorithm. Now let us execute a simple C program in C compiler. So this is the C program for the insertion sort. Before I written here j minus 1, I debugged it to j plus 1. So initially we declare n an array of max where n scans the total number of elements. Array of I scans the elements of the array. We apply then insertion. We declare insertion sort function. The insertion sort has two parameters a and n, where a is the array and n is the total number of elements. Now this is the core logic for insertion sort. We are starting from the second element I is equal to 1. We are considering it as the key value, and in the second loop we compare it with the previous elements less than I. So if that current array of j is greater than key value, we will swap both the elements. So after the inner loop, array of j plus 1 is equal to key. So this is the core logic about insertion sort. Now let us look into the time complexity of insertion sort. Best case has omega of n. If the list is already sorted, where n is the number of elements in the list, this is the best case time complexity, omega of n. Average and worst case time complexities are similar, which are theta of n square and big O of n square. Average case, if the list is randomly ordered, then we get average case. Similarly, in worst case, if the list is in reverse order, big O of n square. So this is about time complexities. Now let us look into the advantages and disadvantages of insertion sort. Advantages are simple and easy to implement. The concept is simple when compared to other sorting techniques like merge sort and quick sort. It is a stable sorting algorithm. It works efficiently for smaller datasets and medium datasets. Efficient for small lists and nearly sorted lists. Space efficient as it is an in-place algorithm. So these are the advantages of insertion sort. Now let us look into the disadvantages of insertion sort. It is inefficient for larger list. So if the list is large, then the time complexity keeps on increases. Because as we see, the average and worst case are big of n square. So if the number of elements in the list increase, the time complexity will gradually increase. Not as efficient as other sorting algorithms like merge sort and quick sort for most cases. So these are the advantages and disadvantages. This is about insertion sort algorithm. Thank you for watching this video. Please like, share and subscribe. If you have any doubts or comments, doubts or feedback, please comment below. Thank you for watching.